All right, today we're going to talk about something that, well, literally holds our entire world together. I'm talking about joining metal. Now, I know it sounds super technical, right? But trust me, choosing the right way to do it is a surprisingly high-stakes game, and we're about to see exactly why. I mean, have you ever looked up at a massive skyscraper and just wondered, how does that stay up? What's stopping it from just falling apart? Or what about an airplane wing at 30,000 feet with all those incredible forces pushing on it? I can tell you it's not just a bunch of nuts and bolts. And this right here is where it gets serious. The secret is all in how they're joined. Choosing the method to join those massive metal parts, it's one of the most critical engineering decisions out there. If you get it right, a structure can stand for centuries. But if you get it wrong, well, the results can be absolutely catastrophic. Okay, so let's meet the big three, the main contenders in the world of joining metal. And to make this super easy to remember, we're going to think of them as three distinct personalities. We've got the muscle, the brains, and the diplomat. So first up, we have welding. This is our muscle, and it is an absolute powerhouse. The whole idea is pretty simple, really. Brute force through extreme heat. You're literally melting the edges of two pieces of metal. Sometimes you add a filler material until they just flow together and become one single seamless piece. The key thing here is the joint isn't just on the metal, it is the metal, and that's what makes it unbelievably strong. Okay, next up, let's talk about soldering, which we're calling the brains. This one is all about precision, all about finesse. So instead of melting the actual pieces you're joining, you use a filler metal, the solder, that has a super low melting point. Honestly, the best way to think of it is like a specialized hot glue, but for metal. And because that heat is so low, it's absolutely perfect for delicate work, when you can't risk damaging any of the components. And that brings us to our third player, brazing, the diplomat. This one, well, it sits right in that sweet spot in the middle. Like soldering, it uses a filler metal, so you're not melting the base parts. But, and this is a big but, it uses much higher temperatures than soldering, and that creates a way stronger bond. Its real diplomatic skill, though, it's amazing at joining completely different types of metals together. Making them play nice when welding just can't. All right, so we've met our three contenders, but how do they actually stack up against each other? This is where we get to the tail of the tape, the critical trade-offs that'll tell you exactly when you should pick one over the other. So, first things first, let's talk about pure strength. And honestly, the difference here is staggering. Welding is just in a league of its own. It's not even close. That's exactly why we use it for things like bridges and ship hulls. Brazing, it creates a really respectable, strong bond. And soldering, well, let's just say it's clearly not designed for any heavy lifting. But of course, that incredible strength, it comes at a price. And it's probably no surprise that the equipment for welding is pretty complex and, yeah, expensive. Now, you go all the way to the other end of the scale, and you've got soldering. It's incredibly accessible, super cheap to get started, which is exactly why it's so popular for electronics and weekend DIY projects. Okay, let's get to the technical heart of it all. If you look at this table, I want you to focus on one row in particular, base metal melts. This is the single biggest difference. See that? It's a yes for welding and a no for the other two. And why? It all comes down to the insane temperature difference. Welding can get hotter than 3,000 degrees Celsius. I mean, that is hot enough to literally vaporize steel. Brazing is in that middle range, while soldering stays below a pretty cool, relatively speaking, 450 degrees. That massive heat gap, it dictates absolutely everything, from the final strength to the skill level you need to pull it off. All right, so that's the theory. But where do we actually see the muscle, the brains, and the diplomat out there doing their thing in the real world? Let's take a look. Well, no surprise here, welding is used everywhere that failure is simply not an option. We're talking about the steel skeletons of those skyscrapers, the massive pipelines that cross entire continents, the very frames of the cars and planes we trust our lives with. In all these cases, the joint has to be just as strong as, or sometimes even stronger than, the original metal. And it's not just about raw power either. It's also about incredible reliability. I mean, look at this. Advanced techniques like friction stir welding, the kind they use on jets like the Boeing 787, can increase the reliability of a joint by more than 25%. Now, in the world of aerospace, a number like that it's absolutely massive. It's a total game changer. Okay, now let's zoom way in down to a much smaller scale, because this is where soldering is the hero. the micro world. Every single smartphone, every laptop has thousands of tiny soldered joints on its circuit boards, and that low heat we talked about is absolutely essential. I mean, can you imagine trying to weld a microchip? You just end up with a useless puddle of melted silicone. It's also the go-to for really delicate work, like jewelry and even some simple plumbing.
So what about our diplomat brazing? Where does it shine? Well, its specialty is creating peace between metals that don't normally get along. A perfect example is probably running in your house right now, your air conditioner. Those systems need to join copper pipes to aluminum parts, and you simply can't weld those two together. But you can braze them, and you get a super strong, totally leak-proof seal. It's also fantastic for things like bicycle frames, where you need real strength, but you can't risk distorting those thin metal tubes with the intense heat of welding.
Okay, we've covered a ton of ground here, so let's boil it all down. Let's say you have a project and you need to join some metal. Here's a quick guide to choosing your champion, and it just takes 3 simple questions. Question 1, and this is the big one. Does this joint need to have the absolute maximum strength? Is it holding up a serious structural load where failure would be really, really bad? If the answer to that is yes, then the choice is easy. You need the muscle. You've got to go with welding for that kind of integrity. All right, question 2. Are you working with anything delicate? Anything heat sensitive, like electronics that could be completely destroyed by high temperatures? If that's your situation, then you need the brains of the operation. Soldering is your answer. It's really the only way you're going to make that connection without frying everything around it. And finally, question 3. Are you trying to join 2 totally different kinds of metal? You know, something like copper and aluminum, where the materials just do not want to fuse together? Well, that sounds like a job for the diplomats. Brazing is going to be your go-to for creating a strong bond in a situation where the other methods would just flat out fail.
So really, if you only remember one thing from all of this, let it be this. Welding is the muscle. It's all about raw power. Soldering is the brain. It's all about precision. And brazing is the diplomat, the versatile negotiator that expertly bridges the gaps. And there you have it, the big 3 of joining metal. So next time you walk by a skyscraper or you look at a circuit board or even just hop on a bicycle, you'll know the hidden science that's holding it all together. So the only question left is, for whatever project you've got coming up, which one are you going to need?